Hello, I'm Professor Von Schmohawk, and welcome to YU. In the previous lectures, we explored some examples of the earliest number systems which were used primarily for counting objects. These counting numbers are called natural numbers. The natural numbers start at 1 and can count to arbitrarily large quantities. As we have seen, Roman numerals are one of many possible ways to represent natural numbers. The Roman system was eventually replaced with the modern decimal number system, which uses positional notation and only 10 numeric symbols. The decimal number system was found to be superior to the ancient Roman system because of the simple rules it uses to create numbers. In the decimal system, there are 10 numeric symbols, 0 through 9, called digits. Depending on the column they occupy, these digits represent the quantity of ones, tens, hundreds, thousands, and so on, which make up the number. In positional notation, the column occupied by a digit determines the multiplier for that digit. For example, in the decimal system, the value of the rightmost digit is multiplied by 1. The digit in the next column to the left is multiplied by 10. The next digit is multiplied by 100, and so on. The value of a number is the sum of all its digits times their multipliers. For example, the value of the decimal number 1879 is 1 times 1000 plus 8 times 100 plus 7 times 10 plus 9 times 1. In any positional notation, each column's multiplier differs from the adjacent column by a constant multiple called the base of the number system. In the decimal system, each column multiplier is 10 times the previous column. Therefore, the decimal system is called a base 10 number system. There are an infinite number of columns in the decimal number system, with each column multiplier being 10 times bigger than the column to the right. However, when writing a number, the zeros in front are normally not written. We can count up to 9 using only the ones column. Once we've reached 9, the ones column starts over at 0 and the tens column increments. As we continue counting, the tens column counts the number of times that the ones column has passed from 9 to 0. In other words, the tens column registers the number of tens which we have counted. This continues until we reach 99. At that point, the ones and tens column start over at 0 and the hundreds column increments. The positional notation system is simple. Every time a column passes from 9 to 0, the next column to the left increments. How is it that we ended up with a number system based on multiples of 10? There is not any good reason for choosing 10 over some other number, other than the fact that people have 10 fingers and probably originally communicated quantities using their fingers. But what if we were cartoon characters with 4 digits on each hand? Is it possible that in cartoon land, everyone uses a number system based on multiples of 8 instead of 10? How would a base 8 or octal number system work? In octal, there are only 8 numeric symbols instead of 10 as in decimal. Instead of 0 through 9, the symbols 0 through 7 are used. The symbols 8 and 9 are not needed. Counting in octal is very similar to counting in decimal. Since there are no symbols for 8 or 9, the highest quantity which can be represented in the ones column is 7. Counting an eighth item causes the ones column to start over at 0 and the next column to increment. So the second column counts the number of eighths. Therefore, in octal, the number following 7 is 10, which looks just like the decimal number 10. After octal 10 comes octal 11, 12, and so on until we get to octal 17. At that point, we go to octal 20. The second column has now counted 2 eighths, or 16. We continue like this until we get to the highest number we can represent with 2 digits, octal 77. At that point, the ones and eighths column start over at 0, and the third column increments. The 1 in the third column represents 8 eighths, or 64. Each column multiplier is 8 times the previous one. Every number which can be written in decimal can also be written in octal, although after counting to 7, the way the quantities are represented is completely different. It is easy to convert an octal number to decimal when you consider how positional notation works. Let's take, for example, the octal number 1750. As in decimal, the value of the octal number is the sum of all its digits times their multipliers. So the number 1750 represents 1 times 512 plus 7 times 64 plus 5 times 8 plus 0 ones, which adds up to the quantity which in decimal is called 1000. You may sometimes see a small subscript 8 or 10 after an octal or decimal number, in case there may be some confusion about which base is being used.